Hello, this is Miss Williams, and we're in topic 6, lesson 2, exponential models. Okay, today we'll be working with that you'll be able to write exponential models in different ways to be able to solve our problems. Okay, we'll be working with 3 vocab, so make sure you have your vocab sheet out. Okay, we're jumping right into our essential question is how can you develop exponential models to represent and interpret situations? Okay, so let's introduce kind of our first model, and that is our compound interest. Now, these formulas we will be given to you. You will just have to know what these mean. Okay, so we won't tell you which one is which, but you have to be able to pick out which one. So, some key things. So here's your vocab word, compound interest. Okay. P is always stands for the principal. So that is that. R is your annual rate. Okay, so remember that is always written as a decimal though. Okay. N is the number of times it's compounding per year, and so that could be quarterly, which would be 4, monthly, which would be 12, semi-annually, which would be 2, those types of things. Okay, and then A is the value of the account after T years, and so T, remember, is always in years. Okay, now N, as you can see, happens in 2 places, so we gotta be careful about that. Okay, so once we have these values, it's a matter of being able to plug them into the right spot. Okay, so we're going to talk about, let's work on just working with the formula. You're going to need your calculator. We're going to write this out as well. Okay, so it says Tamira invests $5,000 in an account that pays 4% annual interest. How much will be in the account after 3 years if it is compounded annually, quarterly, or monthly? Okay, so let's kind of talk about our formula. Here's our formula. Okay, so we got after 3 years, meaning T is going to be 3 for all of these, right? Now, what is this talking about? Remember, we had this a little bit before. This does represent our exponential model. T is really our x. P is really our little a. This is all really our b, which means that if we're 1 plus, right, this should always be growing, meaning getting bigger. Okay, which is typically what we want to happen when we're investing, right? And so let's break some of this down. Let's talk about what is P, what is R, and what is N when we know that T is 3. Okay, so P is our principal, so that should be our 5,000. R is our rate, right? And so our rate is 4%, which is 0.04 as a decimal. Okay, N is what is going to change, and I'm just going to put that in here. Oops. So this is the number of times it is compounded in a year, and so we got annually, quarterly, monthly. Those are what are going to change. So annually would be 1 year, quarterly would be 4 years, monthly, or sorry, 4 times, monthly would be 12 times. Okay, so we are going to plug in our formula and figure out how much it is. So we got P, we got N, and we got R, and our T. Okay, so we got 5,000 parenthesis 1 plus my rate, which was 0.04 over 1 times 1 times 3. Okay, now with this over 1, I don't need to do it, but because we're going to be typing this in 3 times, sometimes it actually helps to type that in as is. So let's go 5,000 parenthesis, we got 1 plus, I'm going to bring in my fraction. Okay, so that was alpha, this button. Some of you have it in a different spot. Some of you prefer your other TI-36 Pro. That might help, whichever is going to type in the fastest or the best. So I'm actually going to fill those in, even though the 1 doesn't do anything. I'm going to raise this to now. When it's in here, some of your calculators are different. If it stays in here, I can just take 1 times 3 and go 3. I don't need to change it. But I want to show you, mine does stay in the exponent, then I'm good. Otherwise, you will have to put a parenthesis around it if it doesn't, if you just have the little arrow, because that's going to dictate your answer. So part of this, I want everyone to be typing this in so that you know which way it works. Okay, so you make sure you match my answer. So we should have, we got $5,624.32. Okay, now not a lot's going to change besides the n, which we're going to see how does that impact our overall answer. So now instead of a 1, I'm going to put a 4 on the bottom, but I'm also going to put a 4 times 3. Okay, so why did I type it in the way I did? It's because I can just hit second entry, and now I'm just going to replace the exact number. So I got a 4 there, and a 4 here. And I get 5,634 and 13 cents when I round it, because we are in money. So we can see that actually compounding it monthly, I'm making about $10 more a year, which in 1 year is not a lot, but when you talk about 5 years, that's 50 bucks, and hey, 50 bucks is 50 bucks. Okay, plus it'll increase every year in addition to that. Okay, so go ahead and see if you can type in the last one for me. You might have to insert to change. So I might have to go 1 and go second insert so that it doesn't override it. And you should have gotten this. Okay, for your monthly. So just practicing the formula, right? Making sure we can type it in correctly. I will tell you, make sure you write down what you are typing in your calculator, because if we don't know what you wrote or typed in and your answer is way off, we'll have no idea which number you messed up or if it was just a typo error. And so that's going to save you a lot of points. So make sure you write down your equation. Okay, go ahead, flip it. Okay, and so we are going to now find, we're going to find out what is our annual growth rate using this formula. Okay, so we have, for our compounded, we have, so for our entrance, everything is still the same. So we're going to start with the same values here. And we are just looking for our annual rate. Okay, so for in 1 year. Okay, so T is just going to be time. Okay, so annual. I'm going to show the first one. We got 5,000. We have 1 plus this 0.04 over 1 times 1 times T. Okay, so annually, right, we already know this. Our growth rate is 4%. Okay, so that, because nothing changes, we're over 1, we're the same. Okay, this will just simply simplify to that. Okay, so what we're going to do now for quarterly. Okay, so let's see what we had put in for quarterly. We had our 5,000. We had 1 plus our 0.04 over 4 times 4t. Okay, so what we're looking for is just, in general, the growth rate over a single year. And so T is really going to be kind of our single year. And so we want to simplify this part. Okay, so we're going to take this 5,000 and we are going to actually type this in our calculator. So 1 plus our 0.04 divided by 4, and we get 1.01 to the 4t. And so what we want to actually do is we are going to separate our exponent so that we can get this just equal to t, not equal to t, but raised to t. So what happens is we're actually going to solidify this and go like that. Okay, so I'm going to raise this to the 4th power, okay, because we're talking about, we're just transforming it over, just trying to see what is the growth rate over just 1 year. We're compounding this 4 times, right? And so that n is part of it, right? But t is just representing 1 year. And so what we get here is this 5,000. Now we would have this 1.0406 raised to the t. And so here is now our growth rate. And so we're going to take out the 1 and we get 0.0406. And I want to make that back into a decimal. And so we actually have this as our annual growth rate, which, as we can see, is a little bit higher than 4, and which it should be because we made more money in this one. Okay, so we're just trying to actually isolate, we're manipulating our equation in a way that we are just looking for what is our just growth rate. So how do I know how much my money is going to grow? Okay, so I want you to try to do that with your monthly. So I'm going to start it off for you. We have the 5,000. We got the 1 plus 0.04 over 12. Okay, so you want to just group your 12. You're going to raise that rate to your 12th power and see what you get. And this is just using our properties of exponents. Okay, so you should be isolating this and all I want is to figure out how much this is. And so we should get 1 1.0407 to the T, which would give us a 4.07% annual growth rate. Okay, so with compounded, we can just talk about why it might be important to only care about just for a year. Now, I'm going to be putting this still in for 3, 5, 10, whatever years, but it's important to look at, okay, when I'm comparing, okay, how much can I actually afford to not have this money for? Okay, there was a decent jump here, right, but a very slight one here, so maybe it's okay to keep the quarterly, or because that might be my better deal or better option, or okay, if I'm long term, that 0.01% is going to make a difference. Okay, so just being able to show what an annual growth rate is. So even though this is how many times it's happening per year. All right. And then, so here's our example. I want you to try plugging it into the formula. You have 2 options. Okay, so pause the video. Go ahead and try. And also trying B is what we did in this growth rate, this annual growth rate, where we're just separating. We're not actually calculating. Okay. Alright, welcome back. You should have gotten your principal as your 3,000. You got 1 plus 0.03 over, we're compounded monthly, which means N is 12. And T in the first one is going to be 10. Okay, that should have been equal to 4,048.06. If I did it again, for 100 years, we should get 60,031.45. Okay, so you're just changing one number because we're still compounding monthly, no matter what. Okay, what is the effective annual interest rate? So we're going to break this down, right? And we are focusing in on just what does this give us. Okay, and that should give us 1.0304, meaning we have about a 3.04% of an effective annual rate. Okay, so that is compounded interest. Okay, so now let me think about this. I asked you for 100 years, right? If I just kept going, right? So if I took our formula, right, and I just kept it going continuously, we can see that this annual growth rate, okay, so look at N, I already took it out, right? This annual growth rate is eventually going to get really, really close to, look, we got 2.7169, 2.718, 2.7182, right? And it's getting really close to this number, no matter what. We're at 1,000 or 100,000. Okay, for the number of times. So as this goes and continually to increase, no matter how many times, it's going to eventually, we call this, converge towards one number, and that number is this growth rate of 2.718. We call that the natural base. Okay, so that is what we would call E. Okay, so here's your vocab word. The natural base E is defined as the value of the expression. So here's what makes E is 1 plus 1 over n raised to the n. As n approaches infinity, E is an irrational number. E is kind of like pi. Okay, so this is why we really don't use E as a variable, because it actually stands for a number, just like pi stands for 3.14, etc. Okay, so E is this number. Now, you basically need to remember it as 2.718 is about what you need to know for E. Now, this is a button in our calculator, so I'm going to show you two places where it is. On mine, those that have calculators like mine, if I go second divided by, so our second is blue, you can see this is E. So this is E to the first. Okay, so there's my number, right, just like we showed. Now, if I want to raise E to a different power, we have second E to the x, which is up here, and that's just going to put any number. Now, I could put 1, get the same number, so I can always just use this button. Instead of knowing where both are, I can just simplify in 1, but I can cube E and get a number. Okay, so this is used for our formula to continuously be compounded. So continuously compounding meaning it's always calculating. Okay, this is an easier formula because we call it PERT. Okay, we still have our principal, which is the initial amount. Okay, we still have our rate, which is a decimal. And then we still have our time in years, so this is in years. And then obviously A is the value. Okay, E is our natural base. That is the number that you're going to type in your calculator. Okay, so you will actually type in E. Okay, so let's talk about this. Again, now it's going to be coming from, am I using continuously compounded or compounded interest? So before, remember, our formula was just compound interest versus continuously compounded. You will have to see the word continuously, which we do. Okay, so we have our principal, right? We got Regina invests $12,600 in an account that's compounding continuously. We want to know what is the value after 12 years, round to the nearest dollar. Okay, and so what we're looking for is we got our P, we got our equation, PERT. Okay, so I need a P, which is my principal, so we got our 12,600. E is E. We got our rate, which comes from our picture. We got 3.2%. So that as a decimal, now even though it isn't a decimal, but is 0.032. And then our time is 12 years. Okay, so we're just going to plug this in. We get A equals 12,600. E raised to the 0.032 times 12. Okay, again, you're going to want to put this in parentheses here, especially because we don't typically, I mean, before we could take 3 times 4 and just get 12, but here, right, we're going to want to actually put it in the calculator. Okay, so I'm going to take 12,600. Now I'm going to go second, my LN, which is my E button, Now if you need to, put parentheses, some of you will, 0.032 times 12, and we should get our answer of 18,498.63, but they said to the nearest dollar, and so we will round that to 499. Okay, so that's compounded continuously. Alright, I would like you to pause the video and go ahead and try for A and B. Okay, welcome back. You should have had your principal as or 125,000. You have R is 0.0475. And in this case we have T is 15. So plugging that all in, you should get about $254,885.32. Okay, the only thing different here is 30, right? And so when you plug this in, you should get 519,732.23 cents. Okay, so those are just working with the two different formulas. Okay, so now we are going to, we got two things left. Okay, so we have Tia knew that the number of instant messages she sent was growing exponentially, so knowing that we can use this. She generated a record of number of IMs since 2018. What is the model that would describe the data? Now, you can see they already show you which one they want you in. So we have three different forms. Remember, exponential, this is just the most generic one. Okay? And so we are trying to find the values of A and B. Okay, and then we're going each year since. Here is the beginning. Okay. And so what we want to do is come up with 2 points. Okay, so 2 moments in time, and we're going to end up using this. Okay, so we have X is the number of years since 2018, and Y is equal to the number of messages. So my first coordinate, we got 6,000 messages for the year 2022, which is 4 years. I don't know why I was starting to write 6, but so from 2018 to 2022, we got 4 years, and we had 6,000 messages. And then we got 5 years, and we have 6,600. Okay, so this is always the type of process you are going to do. We're going to create 2 equations, and believe it or not, I'm actually going to put this one on top. Okay, so that I don't have to rewrite this. And so this equation, right, we got our X and we got our Y. We are looking for A and B. Okay, so this is going to create equation 1. And so I have my 6600 equals A times B to the X, which is 5. Okay, then this is going to create equation 2. I know it's listed funny, but it'll make sense when I do this. And so this equation is our 6,000. We have A times B to the 4th. Now I'm going to actually layer this right underneath here. So here's our system, but systems with exponents work a little bit differently. They actually are pretty smooth. What I'm going to do is actually divide these two. Now, why would that make sense? First off, you got to remember these are separate things. Okay, and if I divide these, this should always happen, is my a's are going to cancel out, leaving me with, now I'm going to use my properties of exponents. I got 5 minus 4, which is just b to the first, or b. Okay, well, what does b equal? Well, I'm going to plug in D600 and divide by 6,000, and I get 1.1. Okay, so I just typed that into my calculator. So that's my b. Now I get to plug that back into one of my equations to find a. So now we need to find a. And so I'm going to just plug it into the first one. So we got 6,000. So this is equation number 1. We got 6,000 equals a times 1.1 raised to the 4th. Well, now I can actually type that in, raise that to the 4th power, and I'm going to divide that over, so really it's going to look like this. And I'm going to get 6,000 divided by my 1.1 raised to the 4th. And I get, and we'll leave it like that. Okay, and so here's my a, here's my b. So what is my equation? Would be y equals 4,098 times 1.1 raised to the x. A lot of times I like to put in parentheses, that way we're not tempted to multiply these two out. Remember, these are separate. I cannot multiply these together because exponents come before multiplication. And so there is my equation that I would be writing. Okay. And so I want you to pause the video and go ahead and find the equation that would land with this. Okay, welcome back. You should have gotten these 2 points. And I'm just layering them as is. Okay, so when I divide this, my a's cancel out, giving me b, and this should have gotten me 1.025. And so now I'm going to plug this back in for the first one. And I'm going to divide by that number and get, I didn't tell you what to round to, so I'll just say 0.2 for your a. Okay, and so we should get y equals 1913.2 times my 1.025 raised to the x. Okay, if you had 0.03, that's okay. Typically we go probably to this third decimal point. Okay. All right. Then, lastly, we've been working with regressions. We've done regressions before. We've done quadratic regressions. We've done linear regressions in Algebra 1. We can actually do the same with exponential. Okay, so we're going to use our calculator for this. So you're going to need your calculator. You need to go to Stat, and you are going to hit Edit. And we're going to go L1 and L2. We're going to create our list. Okay, L1 is going to be our x's, L2 is going to be our y's. Okay, so let's see what we remember from this. So we go to stat, and then edit is right away. Now if there's something in your list, remember you're going to arrow up to your list, hit clear, not delete, clear, and hit enter, and it will clear your list. So again, go up and hit clear, enter, and it'll clear your list. Okay, so remember that days is our x, volume is our y. Remember, I'm just going to hit enter and continue on. So I'm going to go 0, enter, 5, enter, 10, 15, 20, 25. Okay. Then I'm going to do that the same for my y's. Here are my y's. So you can be doing this while I'm doing it. Pause it if you need to wait for people. So I'm going to just write enter data. Okay. Then we're going to hit stat again. So I'm going back to the main menu of stat. I'm going to arrow over to calculate. And now this one's actually down to the bottom of mine. So if I keep going all the way down, I'm looking for, mine is 0. But it would say exponential regression. Okay, so I'm going to hit enter. Notice how my x was L1, so if I did mess this up, I could switch those two, but I'm not. And I'm just going to hit calculate, and that's going to calculate my values, and I got A is 122.327, B is 0.916. Okay, and so there was my regression. I can write my equation just like we were writing it before, and you can see that we should be declining, which we were, right, decaying as we were. Alright, that concludes this. I will write the homework down on the sheet. So T6 L2 homework, you guys have page 299, 12, 13. And 30. All right, thanks.